Hello everyone, this is a a showcase of my suite, which basically what it does is it can take an array from Python, which was coded in Python programming language, and it can pass it to a C++ formatting programming language format. Now it does this basically by utilizing JSON files. So the codes in the suite are both Python and C++, and these are codes which process these arrays to JSON format, which is actually known as Dictionary of Keys format. And I'll be showing you a little bit about like what this all means, of course, in the example. Of course, even though this implies, right, that if you have a file, if you process these arrays to JSON file formats, not only do you have the capability of moving across Python and C++, you could also use this code to move arrays across different programming languages, such as JavaScript, Scala, any program really which you may dream about, you may think about. But of course, I have limited code right now for doing those transformations or processing steps. However, if you would like to perhaps add to the code, right now I have limitations from passing arrays from 1 dimensions to 3-dimensional symbolic representations. If you would like to go, for instance, for do 6-dimensional arrays or beyond, which means these are just dimensions of the axis, of course, you're more than welcome to contribute, and of course you may do that by following the steps here. If you would like to add more functionality so that we can pass these to JavaScript formats and so on and so forth, also welcome to do for open to contributions. Of course, this is open source code. We are in GitHub after all, right? So the first thing I'm just gonna, as I mentioned, I'm just gonna showcase the code and this suite, and how you can make it work. So you're gonna copy the whole repository. I'm just gonna be copying it in my desktop. It's gonna be creating a folder in my desktop. Okay, and I'm just gonna give it a fun name, or actually, I'm just gonna call it showcase. The repository, the directory I'm creating. Okay, you can just like clone this anywhere you would like, really. But I'm just gonna be copying it here. Git clone and the repository. Okay. Once you have cloned the repository, you're gonna access that newly cloned repository, the path. Now you'll see that there are some files here which I've cloned. Of course, the first file is the include file, which will contain only the C++ code, which does the transferring, the processing from C++ code to JSON format. So what you're gonna do is you're gonna declare, send this script to the global user variable location in your computer, and that is basically step number 3. Copy it as a script variable, a global script variable. So to do that, you're gonna be basically doing sudo copy recursive operation followed by the directory, the path, which includes this C++ script, which is this one, then followed by the location in your computer, the global location, which is user/include, and then you're gonna give it Garcia as the directory name, and it's gonna ask you for your password. After you've inputted the password, you should have it declared as a global script. So if you want to check, you just see if it's there, user include, and it's there, bridge.hppp, which basically contains all the source code to do that transformation to JSON file from C++. Okay? Clear. And now we're gonna go back to the repository, to the clone repository. What was it? Showcase. Bridge. Right. So we're just going to do all the work actually in this folder which I created, which is inside my desktop, which is called showcase. Okay, so you can open it, the whole thing with your favorite text editor. In my case, it's Visual Studio Code. Now we are going to start with the first step. After the installation setup, we're going to take some of these. We're going to take some of the information here on the first example for C++. We're going to copy the whole thing at first, of course, and we're going to create a new file. We're just going to call it file.cpp for C++. I'm going to copy paste that code here. You'll see that line 4 now contains the declaration of this script we have declared in our user variable as a user script, as a global script in our computer, which is bridge.hppp, which we've already done. So now you can see that here, right, the first code block will create a vectorized array. So what we're going to be doing is, sorry, we're going to comment out the second code block from lines 15 through 23, because we will just be running the first part, right, of the first code block, which will basically process a symbolic tensor. Actually, I'm going to make it simpler. We're going to process not a symbolic tensor, we're going to process a symbolic matrix, a 6x6 matrix. And of course, if it's 6x6, it contains 36 elements in vectorized form. Right, so we're going to, and all of these elements will just be ones, will have a value of 1. Okay, so we're going to make it, and this symbolic representation of matrices basically is typically done in C++ because we don't for low-level languages we typically do not define matrices in multi-dimensional form. Okay, so this is common practice, and this is why I've designed it to be that way for C++. In Python we actually extract all the information is extracted to multi-dimensional form. All right, so nonetheless, if you make those changes, it will give us now a symbolic 6x6 matrix. Okay, so, and with, of course, in JSON format with name sample.json. Okay, so after you've done that change, maybe I'm been talking too much. You're going to be compiling this file with Clang, and Clang is just another function I've created, and you can also download it on my GitHub, which basically does the compile in a very simple way. You're gonna, I'll be placing the link description. I'll be placing where you can download it also under the video description. But nonetheless, here I'm just gonna do the operation clang file.cpp, and then this will compile your file with a .k extension. Okay, so as you can see now, we have this file, newly created file, which is has a .k extension. You're gonna run it /file. And you'll see now that it has instantaneously created this JSON file. Right. If you want to see it a little nicer, then you can just place it in JSON lint. And you'll see that it has this format. The format of this JSON file, this processed vector from C++, it's now a JSON file, which has as its first dictionary entry, of course, the coordinates of all the non-zero elements in the symbolic matrix, and you can see basically it's all the coordinates in that matrix are made to be non-zero, and of course, which value do they have? They all are, as I said before, they all have a value of 1, and dimensions 6x6. Okay, so after we've done that, we can pass this from the JSON file. Now we can interact with Python. We can pass this whole thing to Python code. So what we're going to do now is we're going to go and copy paste the second example. Copy paste the second code you see in the repository, and we're going to go copy paste it as a new file in a new file called file.py, which will be a Python file. Yeah. I may have not gone through this step yet, so we do not have the Ponte mini library right now, so I'm going to be installing it. So you're going to need to install it as well. Of course, if you follow the direct instructions of the setup, it is the last step, right, of getting the Python mini library. Okay, so we're going to go pip install Ponte. There's also a mini library I've developed and deployed, so you can also just download it by pip install. And after you've done this now, and after you've copy pasted that code in a new Python file, what we're going to do is we're going to comment out the first code block, which is in the creating a new. We have already created this new vector, and we've called this sample.json. So we're going to just be doing the task of the second code block, which is processing that JSON file from C++ to Python. Okay, so to do that is very simple. Python, and then the name of the Python file is file.py. And now you can see that it has, in fact, after we've done the processing, it's given us now the array in Python. As you can see, this is the multi-dimensional array format now. This Python is a little bit more high level than C++. Of course, after we have this, we can even like make changes on the imported array after it's been imported. Let's say we want to, for instance, add some zeros. It's actually the array we define is we've given it the name array form, right? So let's say the first entry we want to make it. Let's say we want to make it 0. Okay, let's actually say that we want to make the first column. The first column we want to make it whole zeros. Okay, so first column will be 0 values. And let's say that we want the last row, the entry on the last row and the last column, let's say we want to make it 6. Okay, we can just define these. Actually, we don't need the first value here. And of course, the name of our array is array form. So after doing that, we can print the newly modified array. After we have imported it, we have made some changes, right? I'm just gonna make changes to array, to matrix, you could say even. All right, matrix. And now we run the Python file again. Python file. And now you can see that the first column we have modified it to just be non-zero. I mean not non-zero, to be a column of zeros, and the last entry it's now a 6 on the matrix. So of course we can go back and forth with this. We can now, after we have modified our array, we could pack it back to JSON format. So we can just type, after doing that, you can type bridge, which is the name of the redefined module, which is Ponte, right? Bridge dot to JSON, and then we can give it a different name. We can give it a modif.json, as in modified. And then of course, what are we trying to process? We are trying to process that defined Python variable, which is array form, which is this array we have. And now we want to reprocess it as the file with that name. So now we just run it again, run Python file again, after we've saved, of course. I forgot to save. Okay, and now as you can see, it's popped out a new JSON file with these modifications. You can place it, you can copy paste, of course, if you want to see it in JSON lint in that website, which I'll also be placing under my video description. And you can see now that the values, we have less values of 1. The last value is 6, and of course we have less coordinates here because it's only dictionary of keys only look for non-zero entries. And of course it's also giving us the dimensions of the final data structure, just so that the computer is wary that we are dealing with that matrix of that size. And so this is how the zeros are indirectly counted for. Okay, so after we've done that, then we can interact back with this modified JSON. We can communicate back with C++, and we can load the JSON file back to the vectorized form. And so we can just go back to our C++ code, comment out the first code block, and comment and uncomment the second block, which basically will process the file. We would actually uncomment line 11 here. Okay, and we will be making a change now. Instead of sample.json, the modified JSON file is called modif.json. So we're going to be doing that change, making that change. And after doing that, you'll see now that, of course, if we clang the file again, the C++ file, by clang I mean compiling, of course. File cpp. Did I save it? Yes. Okay. So we compile it. It will basically send us back this matrix in vectorized form. As you can see, there's no need to define dimensions here because the JSON file format already has those in their dictionary. Okay, so we execute the newly compiled K file, C++ file, and now we'll see that, yeah, we have a vectorized array, which in vectorized form it has zeros on those locations, and the last entry is 6. Now, if we want to, as I mentioned, C++ is more of a low-level language. So if we want to, for instance, make changes on C++ on the matrix, on a symbolized matrix, we may have to do something like, in this case, vector and the dimensions of the matrix, the n. And here we could put like any value ij. Let's say we want to change, for instance, go and in C++, right? Yeah, this doesn't help. Maybe if I just show you really quick. Let's say we want to change the value on the second row and second column to the number 100, right? Then we would have to change this second row and second column, and of course the dimensions of the matrix is 6. So we could do it this way. And if we want to process this newly changed matrix, we could then, what do? Well, we could create the vectorized array from it, right? So let's say we have processed already this file back to vector form. Then we could use the code block on the first code block from lines 11 to 13. We can just paste it below here and just make a couple of modifications, of course. So we're gonna comment out all the lines in that previously copied code block. Okay. And what we're gonna do now is, of course, we had it defined as vector. So this line, remove. It also has dimensions of 6 by 6, of course, because dimensions have been already defined. Yeah, okay, no, that's fine. Of course, we need to use a lot of semicolons here. Okay. So now in this way we can call it modified 2, and we can send it back to Python, of course. And now when we doing that, we just compile again. We will create a modif2.json file. So clang file.cpp, and it just takes a little bit of time, and it gives us an error apparently. Yeah, so in C++ you cannot define a variable twice, so we'll just call it file name 2 here. After you make that change, oh, whoops, you're gonna compile again, and after you compile it, of course, a new file called modif.2 will pop out. So you see now that this file has just been created, which has this new modification, which we can load back to Python. As in this case, we want to load now modif.2. So we go back to our Python code, and below line 10, we can write sample. Well, we of course can comment it out. You can write, instead of sample, it will be modif2.json, which is the name of the newly created file. We can then rerun Python, and of course we want to make changes to matrix here. We'll just delete lines 14 through 16. And yeah, so after you've done those changes, I apologize, you just run the code again. Okay, and what was the name of the file? File. Yeah. And now you can see that, yeah, so we have that change which we made in C++. It's now, after it's loaded from JSON, from its JSON file, now it's this has actually become, once again, a Python matrix from that C++ code. So I believe this may be the end of the video. I just wanted to showcase the versatility of this suite, and I call it suite because it's actually a collection of libraries. It's a library from Python and a small library also from C++. So, as I mentioned once again, you would like to contribute, perhaps go beyond the third dimension, go to the fourth dimension, or if you can see 6-dimensional space, then you can of course have more arrays. And if you want to expand this to have it convert arrays to JavaScript or other programming languages, more than happy to see contributions. Anyways, if you really like the content, if you really like my video, please give it a like. If you like the content and you want to keep seeing more of it, subscribe to my channel. I appreciate you listening and watching my video. Thank you.